sklearnmetrics, pairwise distance metrics. Description: the sklearnmetrics, pairwise distance metrics function is a versatile tool for calculating various distance metrics between data points. It provides a comprehensive set of predefined distance metrics, allowing you to select the most suitable one for your specific application. Inputs: X, the first input array, representing a set of data points. The shape of X is expected to be n samples 1. N features. Y, the second input array, representing another set of data points. The shape of Y is expected to be n samples 2. N features. Distance is a distance matrix containing pairwise distances between the points in X and Y. The shape of the matrix is n samples 1. N samples 2. Input validation: the function first validates the input arrays X and Y to ensure they have a correct shape and data types. Distance metric selection: based on the specified metric, the function chooses the appropriate distance calculation algorithm. Distance calculation: the function applies the chosen distance metric to compute pairwise distances between all points in X and all points in Y. Result output: the computed distances are returned in a matrix format. Euclidean distance computes the straight line distance between two points in Euclidean space. Manhattan distance calculates the sum of absolute differences between coordinates of 2 points. Chebyshev distance determines the maximum absolute difference between coordinates of 2 points. Minkowski distance, a generalized distance metric that includes Euclidean and Manhattan distances. As special cases, cosine distance measures the angle between two vectors, ranging from 0 identical to 1 completely different. Hamming distance counts the number of differing bits between two binary strings. Jacquard distance calculates the dissimilarity between two sets, based on the ratio of their intersection to their union. Scatter plot: visualization of data points with distances represented by lines or colors. Heat map: a graphical representation of the distance matrix, with color intensity reflecting distance magnitude. Dendrogram: a hierarchical tree diagram that visually clusters points based on their distances. Metric specifies the distance metric to use for calculations. P for Minkowski distance controls the order of the Minkowski distance. W for weighted Minkowski distance, an array of weights for each feature. None: the distance metrics function itself does not incorporate uncertainty estimation methods. Bootstrap resampling: to estimate the uncertainty in distance calculations, one can repeatedly draw random samples with replacement from the original data and calculate distances on these subsamples. Jackknife resampling: similar to Bootstrap, but samples are drawn without replacement. Challenge 1: handling missing values. If the input data contains missing values nans, the function might produce unexpected results or raise errors. Sample use case that resulted in challenge 1: input arrays with missing values leading to inaccurate distance computations or errors. Fixes to challenge 1: pre-process the data by handling missing values before using distance metrics. This can involve imputation techniques like mean-median imputation or dropping rows columns with missing values. Challenge 2: computational complexity. Calculating distances for large datasets can be computationally expensive, especially with complex metrics. Sample use case that resulted in challenge 2: calculating distances between thousands of points. Using a computationally demanding metric might take a long time. Fixes to challenge 2: consider using a more efficient distance metric, or employing dimensionality reduction techniques to reduce the number of features. If possible, use optimized implementations provided by libraries like scikit-learn. Challenge 3. Selecting the right metric. Choosing the appropriate distance metric depends on the specific problem and characteristics of the data. A poorly chosen metric can lead to misleading results. Sample use case that resulted in challenge 3. Using Euclidean distance for data with a nonlinear structure might not accurately capture the relationships between points. Fixes to challenge 3. Carefully consider the nature of the data and the desired outcome when selecting a distance metric. Explore different metrics and analyze the results to determine the most suitable one for your task.